So the secant of 0 is the reciprocal of the cosine of 0, right? And the cosine of 0 is 1, so the secant of 0 is 1. The tangent of 0 is 0. Did I get those right? You guys can be double checking my work with a calculator or whatever. I feel like doing this one in degrees. I don't know why. We only have to go to pi halves. So I'm just going to go ahead. We could even do like 15-degree increments if we decided we needed to, just to make sure we fill in enough gaps here, because all we need to do is go to 90. Okay, so I'm going to do the ones that I can do in my head, but if you guys want to fill in decimals and tell me what they are later. I made all this work with this separate table and I don't even need it. Oh well, it's good. Okay, so cosine of 30 would be square root of 3 over 2. So that would be 2 over square root of 3. So we need a decimal for that. And then tangent of 30, isn't that one 1 over square root of 3? Because it's sine over cosine, which would be, yeah, it's been a while since we've done these. Okay, secant of 45 is square root of 2 over 2, which means it's just square root of 2. Oh, but wait. Yeah, because that's the reciprocal. Okay. And then tangent of 45 is just 1, right? And then secant of 60, cosine of 60 is 1/2, so secant would be 2. Yes. So what is it? Okay. All right, and then 75, I don't know. I'm skipping. And then 90, cosine of 90 is 0, so that would be undefined. And then isn't the tangent of 90 also undefined? So that makes sense that we can't include pi halves. It's just undefined there. Okay, what, Adrian? Sure. .9. Okay. And tangent? Okay. And then can you do square root of 3 and 1 over square root of 3 for me? Okay. And, oh, square root of 3 is just 1.7, right? We skipped 15. I don't know if we want to throw that in there. 0.27 for secant. Got it. Okay. Yeah, because secant should be above 1. All right. Well, okay. Just so that we have a differentiation there. Okay. So our numbers are going, they're all positive. Everything's positive because it's first quadrant. So I'm going to go ahead and put my axes over here. So I have first quadrant. And then our numbers go as high as 4 and not higher. So what if I count, is that too big if I count by 4s on this particular graph paper? I don't know what your graph paper is like. I'm just trying to fit it to be most accurate. Okay, so we have 1, 0, which would be right here. And we have 1.04 and then 0.3, so that would be about right here. Only closer to 1 than that. Here, I'm going to move that over because it's almost just directly vertical with the other one, just not quite. Okay. And then we have 1.2 and 0.6 and then 1.4 and 1 and 2 and 1.7. Wait, I wasn't putting these quite the right place because I'm counting by, oops. I was messing up my scale here. Okay, so 1.2 should be closer to that line. And 1.4 should be closer to that line because that line would be 1.5. That's better. All right, and then we have 2 and 1.7. So that would be about there. And then we have 3.9. Boy, that shot up fast. And 3.7. So, I don't know, maybe. Okay, so 3.7 would be about right there. That's interesting. All the points are really close together at first, and then it shoots up. So that I think our point where it never gets to, I feel like is probably, I don't know, how far is this going if we get as close as possible to pi halves? Maybe we should do like 89 degrees. Just see what that does, since we're doing degrees in calculator. Anyway, yeah, throw those. Sure, throw in whatever you want that's as close to 90 as we can get without going undefined. Whew. So it's going to infinity. 579. Okay. Oh, fine. Either way, big number off our graph. Interesting. That doesn't surprise me. 500 what? So it's really just 573. So the point, my whole point in that was to realize that shoots off into outer space, more or less. And then we have this point at like 573 comma 573 approximately, where it reaches and ends there, but it doesn't really end. It just keeps getting infinitely close to that open circle, right? So that's hard to put on our graph to actually show that happening. Anyway, interesting problem. That was quite a bit different than the other one, so it was probably good for us to kind of look at. Sorry, my connectors are really bad. So I'm going to put an arrow there that means it goes for a long ways beyond that and gets closer and closer to that point, but never gets